Dr. Moore. We are going to be talking in this lecture a little bit about measurement, a little bit of review, and then discuss variable construction and how to recode and transform your variables in SPSS. So, measurement in a social context is a little bit more difficult than just typical measurements. We can't always just pull out a ruler to measure the exact concept that we are interested in. So, you know, difficult to measure things like social capital, all sorts of policy and management things, diversity management, very, very difficult to measure, or can be difficult to measure. Um, so, uh, as you'll remember from your previous class on research methods, measurement, to do measurement, we first have to establish a conceptual definition of the concept that we're trying to measure. And so, a conceptual definition, according to O'Sullivan, Russell, and Berner, is just what one means by a concept. But they go on to say, give an example to show how difficult measurement can be. They say, consider the concept of alcohol abuse. Its definition could include physical or physiological symptoms due to drinking, inability to meet work, social, or family obligations due to drinking, binge drinking, or self-identification of a drinking problem. The appropriate conceptual definition depends on a study's purpose. So a university wanting to identify the extent of alcohol abuse may define it as involving binge drinking. However, an employer wanting to identify sources of workplace problems may define it as drinking that affects work performance. Or a physician making diagnosis may define it as involving some sort of verifiable system. So, all these different people may conceptualize the problem a little bit differently, and it's based on the purposes of how they're going to use the concept. So the operational definition, or how we operationalize it, comes from the conceptual definition, and it details how we're going to measure the variable. Things like, and this comes from O'Sullivan, Berner, and Russell again, they say survey items and their responses provide examples of operational definitions. If the conceptual definition of alcohol abuse was whether or not a person indulged in binge drinking, the accompanying operational definition of alcohol abuse might be alcohol abusers who are persons who answered yes to the question, did you drink 5 or more drinks of wine, beer, or hard liquor at one time during the past month? So you can operationalize it that way, just yes or no. Did you engage in 5 or more drinks in the past month? That's just a dichotomous measure. Or another example would be a Likert scale type item where that maybe ask the person, do you believe that you have a problem with alcohol abuse, from strongly disagree to strongly agree. In that case, there would be several categories of possible responses. So how we conceptualize it influences how we can operationalize it. Also, we have the availability of data that often influences how we operationalize a problem. Also, in political science, public policy, and public administration research, we often use data from government agencies to try to operationalize a problem. So if we were studying alcohol abuse at the city level or the county level, one thing that we might use is an indicator variable like the number of DUIs in the county might be an indicator for alcohol abuse problems at the city level. So we have different conceptualizations, operationalizations, and sometimes we use indicator variables to capture the concepts that we're most interested in. What matters for this class is that how we measure a concept is going to influence the choice of statistical techniques that are used. However, just because a variable is measured in a certain way doesn't mean that we can't change it to be measured slightly differently. So, for example, we may take a measure that is continuous or nearly continuous, or let's just say ordinal, like do you believe you have an alcohol abuse problem? From 1 to 5, strongly agree, strongly disagree. And we can make it dichotomous. We could say those that either agree or strongly agree or agree are one category, and all the rest, neutral and strongly disagree, would be all other. So we can change that into a dichotomous choice. And so how a concept gets measured is important, but we can also in our data sets sometimes compute a different variable from other variables, and so that's what this lecture is about. Some more review that we talked about in class the other night is that in SPSS there's 3 types of measures. There are scale, ordinal, and nominal. Scale, of course, approximate interval ratio level measures. Ordinal have some sort of ordering to them, higher and lower, and nominal are just categories. So you can see in the SPSS screenshot that I took from the GSS, we have age as a scale variable. We have so it's almost a continuous variable. We have marital status as a nominal variable. So how somebody is married, whether they're married, not married, widowed, divorce. There is no higher or lower ranking to them. So they're just categories, so they're in the data set as nominal. And then, of course, degree, there is some ordinality to that. So if you have less than high school, junior college, there's a degree ordering to that. So those are ordinal variables, and so we can change these variables around, calculate new variables from variables. But let's be aware of the 3 different types of variables in our data sets. So if we have a nominal variable like race that we may want to recode. Recoding variables is one of the most important and frankly, it's the thing that most people spend most of their time on when they're doing analysis, is calculating new variables, recoding them, because the data doesn't come to us exactly like we want it. So maybe, for example, we have 3 categories of race in our SPSS data set. We have white, black, and other. And let's say that we want to do a bivariate analysis that looks at one category of race relative to all the others. Well, in the data set, we have 3 categories. What we really need to do is combine it down to just 2. So in your homework, there was something interesting about black and degree. And so maybe we want to compare black to all other categories in a box plot. So we would need to combine categories 1 and 3. How do we do that? Well, we use this command in the under transform called recode into different variables. And so when you open up SPSS, you will see that we have transform and recode into different variables, and we're always going to use that because we want to keep our data, and if we recode into the same variable, it's going to write over the variable and we won't be able to transform it again. So it's always best just to use that recode into different variables for your data analysis. So once we do that, we're going to first bring that numeric variable race into this middle column here, and then give the output variable right here a name, which in this case we'll just call black, and then we need to click on old and new values. Once we do that, we need to input new values into the old values. We're going to tell the computer what the old value is and then what we want the new value to be. So in this case, 2 was the number in the data set for black, and in the new black race variable, we're going to make it as a 1. So we'll put a 2 and then a 1 and then click add. And then we're going to select all other values and then put them as 0 and then add and continue. Now there's no missing in this data set. So if there are on this variable, but if there are missing observations, we need to do an additional step, and that is put old value system or user missing, and then over here in new value system or user missing, and then click add and then continue, and that will just keep those missing values as missing, and won't change them into that 0 variable. So then once we're done adding our new values into this list right here, we're going to change the 2s into 1s, and we're going to change everything else into 0s. Then we're going to click continue, and this will generate the new variable for you. So you can do that with all sorts of variables, and we do this because we can use the recode and transform commands to create new variables that are often needed or fundamental to the analysis that we're doing. Sometimes we can't do an analysis with 3 variables. We need it to be broken down into dichotomous variables. Or sometimes we need, maybe we want a continuous variable to be changed into a dichotomous variable. So years of education would be an example of that. So let's say we have a number of years of education, and what we really want to know is people with a college degree or more. And so maybe we put people with 16 or more years of experience or of education as college degree or more. Sometimes some categories of a nominal variable don't have that many observations, so you need to combine it into other smaller categories, kind of similar to what we did with white and other in the example. And I would just say be careful with missing data. Especially if you're using all other values, then the missing can be coded as a 0. So the key to that is just use that system and user missing equals system and user missing. Once you're done recoding the variable, use summary and frequency tables that you can find under the descriptive statistics to make sure that you have the same number in each category. So if you look at the original variable of race in the data set, we have white, black, and other. There were 1,559 white, there were 281 black, and 183 other. So we should have, when we recode the variable, we should have 281 black, and then all the rest should be zeros because that's what we told it to do in the data set. We can also use the variable view. We can set give it a descriptive label when we create a new variable. It doesn't come with a descriptive label, so you probably want to type in the descriptive label, how you created the variable, or what variables it comes from. And then you can give the values labels so that everyone knows what those are. Once we have created our new variable, we can use it in our analysis. As we discussed, we ran a frequency of the new variable race equals black. We'll see that there are 281 ones, like we said, and 1,742 zeros in the data set. We can also do other sorts of analysis with it. We can do a box plot. This compares black, which are the ones, to all other races, which are 0. In the data set, we'll show in future classes how we can then use this dichotomous variable in other analysis like regression. The other thing that you may have to do, definitely you'll have to learn to recode variables, but we'll also probably have to compute some variables. When we compute a variable, we're basically just adding, subtracting, dividing, multiplying, basic mathematical computations to create a new variable. To do this, we use the compute variable under the transform heading to create a new variable. I think Sweet and Grace Martin have a particularly nice description of how to do this in Chapter 4. So to create a variable in SPSS, go to transform, compute variable, give your new variable a name in the target variable text box, and then insert the mathematical equation. So you can see here that right here we have the target variable, and then we have our numeric expression. If you can't read that, just zoom in from your PowerPoint slides to read that expression. And once we type that expression in, then we click OK, and it creates the new variable for us. In that previous screenshot, we calculated the percentage of all crimes that are burglaries in the states. In the new variable name, we gave it a new variable name, burg PCT, for burglary percent of all crimes. Probably want to use short names. We can't have spaces in our names. Either type something that doesn't have spaces in it, or use a underscore to indicate a space. Then enter the formula in the box that says numeric expression. So CRS 50 is burglaries, and CRS 29 is all crimes. So you'll just divide CRS 50 by CRS 29, and then multiply by 100, because that changes the proportion into a percentage, as expressed in percent, and click OK. Let's go back and look at that. So we have the target variable, Berg percent. We have the numeric expression, CRS 50 divided by CRS 29. Click OK. You should see it down in the you should see the new variable in the data view once you click OK. So once we have our new variable, you can label the new variable, and you can you won't necessarily need to probably give it values, because they're usually scale variables that you're creating with the compute variable command, but at least give it a label so you remember how you created it. We can then use the new variable in analysis. We can do descriptive statistics of the new variable. We can graph it, and we can conduct inferential statistics with it, which of course will again be the topic for future classes. So here is a histogram of the percentage of crimes that are burglaries in the 50 states. We can see it peaks a little bit before 20%. There's a little bit more information there than I anticipated, but that's okay. You'll see this in your homework. So I'm going to move on quickly. So your homework for this little PowerPoint lecture is to do Sweet and Grace Martin Chapter 4, Problems 1 through 3. You'll compute a variable or two variables and recode one variable, and that will give you the idea of how you compute and recode variables. So that is the conclusion for this week. I look forward to seeing you in class. Thanks. Bye.